All right, hi guys. Hi guys, Miss Kelly here. We are taking a look at our next topic, which is still about inverses. So now we're going to be looking at taking these inverses and putting them to a graph and talking about some critical points or some special points that are going to happen with these graphs. So let's start off with just reviewing a little bit from our last video about switching the points. So if I have a table of values here for f, the original f of x, the inverse f inverse says to switch the order. So -2, 3 becomes a 3, -2. Sorry, let me shrink that down a little bit. All right, so again, we have 3, -2. Now let's look at the next one. If we have -1, 1, switching them becomes 1, -1. 0, -1 becomes -1, 0. 1, -3 becomes a -3, 1. And then our last point becomes -5 and a 2. So what we're going to do now to talk about the graphs, we're going to graph the original and we're going to graph the inverse and see if we can come up with a pattern here. All right, so let's take a look at this grid. All right, so my first point from the original f of x, we have -2, 3. So I'm going to make this just a little bit bigger now. So we have -2, 3. So there's our first point. -1, 1. -1, I'm sorry, 0, -1. 1, -3, and 2, -5. All right, so again, these are the original points, f of x. So this is f of x. So now let's get our inverse up here, and we'll take a look at the inverse graph and see if we can get a relationship here. So now I'm going to graph the new points. So we have 3, -2, 1, -1, 0, I'm sorry, -1, 0, -3, 1, and -5, 2. So here is f inverse of x. So this one is f inverse. Whoops. Okay, f inverse of x. So we want to see if we can find a relationship about those two graphs. And one of the biggest things that I noticed right away is that they are a reflection of each other. All right, these are a reflection about each other. So these are a reflection. All right, so this function is a special function when we discuss inverses and specifically inverse functions. So we've created what's called a line of reflection here. So between these two graphs, there is a line of where they flip over, what's creating again, that mirror image. Okay, so there's my line of reflection. I have a reflection line where they have flipped over. So specifically, line of reflection, like it says there in the box, that is a function and its inverse share a special line of reflection. And the line of reflection is the parent linear function, which we remember from beginning of the year is the function y equals x. So that y equals x line is what's causing this inverse to make that reflection. Now, when we decide if it's a function or not, it all depends on what's called the vertical line test, which we've talked about in the past. And like last video, for a graph to be a function, your x values cannot repeat. And what the vertical line test does is it says the graph is a function if a vertical line can be drawn anywhere on the grid. And it does not cross the graph more than one time. If it crosses twice or more, then that picture is not a function. So let's try some examples here and take a look and see if in fact we have a function or not. So we have a linear function here on the grid. Create a table of values representing just the inverse. And then we're going to graph that inverse on that graph and then talk about some special things happening. All right, so let's get our inverse. So f of x is on the grid. we need F inverse of X. Do not get down. So I have the first point 0, 4. So reverse that, 4, 0. Second point is a negative 1, 2. So when I reverse that, 2, negative 1. And my third point, negative 2, 0, becomes a 0, negative 2. All right, so let's graph these new dots and see what happens. So we have 4, 0. Okay, there's our first point, 2 and negative 1. And then our last one, 0, negative 2. There's our inverse. So here is F inverse of X. So let's get those critical points that we need. All right, so what are the intercepts, meaning the x-intercept and the y-intercept of f of x? So our original. So an x-intercept, again, is where they cross the x-axis. So for our original, we have negative 2 and 0. And our y-intercept, where we cross the y-axis, 0, 4. So let's see what happens to our inverse now. What are the intercepts of the inverses of f of x? So my x-intercept, 4, 0. My y-intercept, 0, negative 2. So even they switched places. The numbers switched and the intercepts switched. So lots of things are being switched around here. So let's see if we can figure out now, are they in fact functions or not? So is the original one a function? It is. Check out your x's. Nowhere do these x's stack up. I'm going to draw an imaginary line here in blue. So no matter where I draw this vertical blue line, it only hits the original graph one time. So it is a function. Now imagine that same line when it's hitting the inverse line. No matter where I draw a vertical line on the inverse, it only hits the line one time. So they are both functions. So both of them are functions. So we have a function because the x's don't repeat, or because it passes the vertical line test. So passes the vertical line test. And same thing for the inverse. The inverse is a function because it passes the vertical line test. All right, so let's try a new kind of graph here. A quadratic function is shown here on the grid, h of x. Does this original graph have a maximum or a minimum? Right now it does have a minimum value because it does have a lowest point at your coordinates 3, 4. All right, now this point represents again the lowest y value on the function. And again, is it a function? Yes, because it's going to pass the vertical line test. The vertical line test. All right, now draw the inverse and then find its minimum value, minimum x value. So let's take these coordinates and let's switch them out so that we can regraph this. All right, so for h inverse of x, we have 1, 8. So reverse that for 8, 1. So there's our first dot. And then we have 2, 5. So reverse that for 5, 2. There's our next one. Then I have 3, 4. Reverse it to make 4, 3. 4, 5. Reverse to make 5, 4. And then our last one, 5, 8. Reverse to make 8, 5. All right. So there is our inverse graph. H inverse of x. So this time, draw the inverse and find the minimum x. So since h of x has a minimum y value of 4, then the inverse has a minimum x value of 3. Is h of x, h inverse of x a function, y or y not? This time the inverse is not a function. If I go back to that graph and I drop in a vertical line on that graph, it is hitting that graph, that inverse, more than one time. So it fails the vertical line test. Making it not a function. All right, guys, I hope you enjoyed our little video here about inverse graphs and how to find some of our critical points. Stay tuned for our next type of inverse, which is dealing with domain and range. All right, bye, guys.